Bismillahirrahmanirrahim. Dear students, Assalamu alaikum. I am Razi and we are doing chapter number 6. Dear students, chapter number 6 is about sequences and series, and today we will start from the arithmetic means. Students, in matriculation we already have learned what is arithmetic mean. The middle term of three consecutive terms is named as the mean, arithmetic mean. So middle term of three consecutive terms in AP is the AP between the extreme terms. Let A be the number between two numbers A and B. If A, capital A and B are in AP, then capital A will be equal to A plus B divided by 2. This is the formula to find the mean term or arithmetic mean. So we apply this formula to first question. Students, we are going to start 6.3 and today inshallah we will do 6.3 and 6.4. So first question is, find the arithmetic mean between x minus 3 and x plus 5. X minus 3 and x plus 5 are two terms and we have to find the arithmetic mean between these two terms. So we use the formula arithmetic mean is equal to a plus b divided by 2. So if we add x minus 3 plus x plus 5 and divided it by 2, we will get 2x plus 2 divided by 2, and taking 2 as a common, we will get x plus 1, and the 2 in numerator will be cancelled out by the 2 in denominator. So the required arithmetic mean is x plus 1. Moving on, students. Next question is question number 6. Find three arithmetic means between 3 and 11. Remember, students, whenever we have to find two or more arithmetic means between two numbers, we suppose the arithmetic means as a1, a2, a3. So a1, a2, a3 are three arithmetic means between 3 and 11. Then this sequence will be 3, a1, a2, a3 and 11, and all these will be in AP mean arithmetic progression. So, and I already have told you what is arithmetic progression, in which the difference between two consecutive terms remains the same in all the series. So a1 is equal to 3, the first term. a5, which is 11, can be written as a1 plus 4d. It's a formula when a series is in arithmetic progression. So we solve this equation a5 is equal to a1 plus 4d by putting the values. a1 is equal to 3 plus 4d is equal to 11, as the fifth term is 11. So move 3 towards right, we get 4d is equal to 8, and when we divide the both sides by 4, we will get d is equal to 2. So students, we have a1 and we have a d. If to find the two or more arithmetic means in a series, we must have the value of a, the first term, and the value of d, the common difference. So when we find a capital A1 means the second term of our progression, we will use the formula A1 plus D, and we have 3 as a A1 and D is equal to 2. So 3 plus 2 is equal to 5. And when we have to find capital A2 means the third term of our progression, we will use the formula A1 plus 2D, and putting the values 3 plus 2 into 2 is equal to 3 plus 4 is equal to 7. So far, if we will have to find the A3 term, which is the fourth term of our progression. So we will use A plus 3D, 3 plus 3 into 2, 3 plus 6 is equal to 9. So the 3 AMs mean arithmetic means between the given numbers are 5, 7 and 9. Moving on, students, we are going to start 6.4 as well, and 6.4 is about the sum of arithmetic series. If the given progression or series or sequence is an arithmetic sequence, and we have to sum the series up to some term, we will use the formula which is about the sum of series arithmetic sequence up to nth term. So Sn is equal to n divided by 2 into 2a plus n minus 1d. This is the formula we use to sum the series. So we start from the question number 1. We have given a series 3 over under root 2 plus 2 into under root 2 plus 5 over under root 2 plus so on up to A13, and we have to find the sum of the series up to 13th term, as the last term is written as A13. So we have come to know that we have to sum the series up to 13th term. The first term is 3 over under root 2, and if we find the common difference d, which is equal to 2 under root into under root 2 minus 3 over under root 2 is equal to under root 2 into 2 minus 3, 4 minus 3 is equal to 1 over under root 2. If we subtract 2 into under root 2 from 5 over under root 2, we will again find the same common difference 1 over under root 2. So the given series is in arithmetic progression. So n is equal to 13. Putting all these values in Sn, which is the formula to find the sum of the series, n is 13, and by 13 by 2, so 2a1 is 3 over under root 2 plus n and 13 minus 1, and d is 1 over under root 2. Now we solve this equation as 13 over 2, and the remaining part of the this sequence is 6 over under root 2 plus 12 over under root 2. Denominator is same, so by taking LCM we will get 18 over under root 2. 18 will be cancelled out by 2, and the remaining denominator is 13 multiplied by 9, which is equal to 117, and the denominator is under root 2, which is the required sum of the series up to 13th term. Moving on, students, today's last question, we are going to solve question number 6, and we have to find the series. The nth term is given and we have to find the series. Students, very simple question. When we have to find the first number of the series, we will put the value of n is equal to 1, and by putting the value of series is equal to 1, 2, 3, 4, so on, we can find the series, and you can find 3 or 4 terms to make this series. So first value is s1 is equal to 1 into 2 into 1 minus 1, which is equal to 2 minus 1, and a1 is equal to 1. Hence the first number of the series is 1. By putting the value of n is equal to 2, s2 is equal to a1 plus a2. So 2 into 2 into 2 minus 1, 4 minus 1, 3, 3 2 is 6. So 1 plus a1 plus a2 is equal to 6, which means a2 is equal to 6 minus 1, and the value of a2 is 5. Similarly, s3 is equal to a1 plus a2 plus a3, and first we find the value of a3, which is equal to 3 into 2 into 3 minus 1 into 3 into 6 minus 1, and it is 15. And we already found out the value of a1 and a2. 1 plus 5 plus a3 is equal to 15. 15 minus 6 is equal to 9. So students, we have found out the 3 numbers 1, 5 and 9. So the series will be 1 plus 5 plus 9 plus so on is the required series. That's all from my side, students. Practice at homes, and you will be perfect. And have a good day. Allah Hafiz.